I've got 3.5 megawatt of on grid. Mainly a phase with run DG. That's one thing I want to know. Second thing is SCADA, which are connected to main three substations. We don't sell up to the substation. Like everything we want to plan to IoT or vice versa.
So decided I came from Delhi itself, and I wanted to meet iPLON team. Basically, one thing is that I'm selling their product in North India. Here I came to learn this new terminology because it's new for me. I know the office card, I know the RMS system, I know the TG, but this is new for me, so I want to learn this one. And also meet iPLON team as a
morning everyone. Myself Blake from Malik. I just last couple of years I was not for this operation. Also, I just came here just to refresh myself in this field and connect the right content. So I came here just without anything. No, see, now what we are doing solar simulations. This is a control normal control. So basically, my company is a power plant and oil and gas field. Thank you. Just want to know about the systems and also the what the new system and your so know more thank you.
so happy with iPLON system. Thank you.
Good morning, sir. Myself, I want to learn about industry knowledge of energy. I came to know that in North India using 90% of green. How Europe is implementing? Why India is like? Recently, I came to know that our electricity minister. Recently, electricity minister recently announced state government is going to 430 megawatts. He also about 11. Why government is that way? India is still committed that about 2030 our green energy will improve. So I want to know and really Thank you.
Good morning, everyone. This is Ram from Wave Energy Solutions, and we are into distributed solar businesses. We just want to understand what are the future problems that renewable energy is going to face, and how we need to address it, and how we need to upgrade ourselves to continue this business.
Good morning, I'm Praveen from Guna Solar EPC company. So the purpose of our coming here is to know more about this iPLON products and how we can use it in our projects in future.
Good morning, everyone. Myself, ADC from Dr. India Education and Research Institute. I'm a research scholar. I'm doing my research on smart meter, means networking of existing metering infrastructure to make it as a smart. So I'm come here for learning some knowledge about how networking is happening in smart grid. That's all, because it will be helpful for my research. Thank you. Hello everyone, this is Mahita. I'm from India Education Research Institute. I'm a research scholar. So I'm doing a project on electrical vehicles. I came here to know about, gain some knowledge regarding my project. Thank you.
Good morning, everyone. My name is Prem Kumar from Renewable Energy Scenario. We basically work with World Bank and United Nations on various transmission and distribution projects and full decommissioning related projects. So I'm here to understand how the renewable energy disconnected battery systems and renewable energy systems are operating. So just to know, understand the knowledge on these aspects.
Good morning, everyone. I am Anto Joseph from Renewable Cogent Group. We work in carbon accounting and greenhouse gas emission reductions, mainly related to renewable energy projects. So our need is to understand the dynamics in monitoring related to carbon accounting, mainly with respect to battery energy storage systems. Good morning, all of you. This is Dr. Mahima Lindsay from Hindustan University. Already we are having a very good bonding with iPLON because our students are already they're doing the internship. They are also the part of iPLON. We are very happy to be here as a team, and we are also doing projects in microgrid, electric vehicles, and other automation, etc. And I hope it will be a good session, and it will be helpful for us in the future for a good research collaborations and doing more projects. Thank you.
So, good morning, Manada, present here. I am Dr. A.K. Parvati. I am coming from Hindustan Institute of Technology and Science. I am Professor and HOD of Degree Department. As Dr. Mohiban has told, we are having a MOU with iPLON. Our students are having internship in iPLON, as well as we have had a session. We have had a live demo session in our university by iPLON guest lecture, as well as many student activities. So we are looking forward, sir, for a better, more collaboration with you, research as well as training. Thank you, sir. Yes, sir. Thank you, sir. Yes, sir. Thank you, sir.
Thank you. I am Dr. Kanda Kumar, heading the Department of Computer Science and Engineering at Hindustan University. Thank you, sir. We are also looking forward for the wonderful opportunity with more activities in renewable energy. And our university has a lot of solar energy sources. So we are harvesting a lot of energy from that. And as ma'am said, we have a strong tie-up with the iPLON, and our students, my MTech students are here, and our faculty are here. So let us see for more collaboration, and looking forward for more fruitful session. Thank you. Yes.
Good morning, once again to all of you, and I would like to say thanks to all of you for coming to this session and to give the introduction about yourself. And also, I would like to take the opportunity to introduce myself and also the other team members also. So, my name is Rahul Sharma, and I'm leading the sales team here in iPLON. And also, of course, I would like to introduce other team members also. So, we have Mr. Bharat. So, he is basically responsible for the sales and BD activities in Karnataka region. And then we have Mr. Shivnath. Shivnath is also leading the human resource team, and also he is responsible for the sales and business development activities. And of course, then other team members, if you see on the front side,
and know-how of Stadtwerke Schwäbisch Hall and may thus focus on your core businesses.
Okay, good morning. I'm Peter from the AP Energy. The next slide. So, before I'm now in semi-retirement, before I was the head of department network control by power company Schwäbisch Hall. I worked for the power company Schwäbisch Hall 40 years. And in June this year, I have two options: to buy a motorhome and drive around Europe or other countries, or create my own company. I start on the 1st of June my own company, AP Energy Solutions. I'm also a doctor, and also a surprise for what hacker possible to enter the system was not all in closed loop, also from Austria or from
Hello. Teams, I request you all to settle down as we will start the session. Hello teams, am I audible? So, we can start the session in 2 minutes. Please settle down with your coffee cups itself.
இந்த ஐபி அதே ஐபியில் வச்சாலும் கிடைக்க மாட்டேங்குது.
So I request all the iPLON teams to ensure the teams to settle down as we are going to start the next session. Please get settled down. So the next session will be like our sales director, Mr. Rahul Sharma. He will be presenting the iPLON products and services which we are sharing to our customers for this RE growth in the renewable part. So he will take over now.
Hello, am I audible to everyone? Is it better now? Good. So I hope you all had enjoyed your tea. So, but sorry to trouble you because we are running out of the time and we don't want to delay our the live demo in the second half. So we will now basically with this presentation I'll give you the walkthrough of what basically iPLON India is doing right now. So what all products, services and solutions we have in our portfolio as of today. And of course, there are a lot of scope for the expansions and that I'll be showing you further as well. So if we classify what basically iPLON is, we have to offer basically, if I put this in contrast with the problem statements also, of course, one is the grid stability, as you have heard in the earlier presentations also. Grid stability is one of the, because when we are putting more and more decentralized renewable energy to the grid, so it's become very important for the plant network operators to keep the grid stable. And then of course they have to follow some certain criteria and which we also called as a grid codes also. So based upon the grid code requirements, when it comes to the utility scale projects, so we have the power plant controller. I'll show you the details later on. And when it comes to the commercial and industrial applications, because as we know, our grid infrastructure is not that stable, so we need to have keep the production line running, some alternate power resources also, for example the diesel generator. So we also make sure once the solar is installed, then how we make sure the plant availability, the solar availability should be always on the higher end. So we also make sure to synchronize the diesel generators with the solar power also, and at the same time we also make sure to have the reverse power protection as well for the diesel generators as well. And then of course on the rooftops, for example in Tamil Nadu itself or in Uttar Pradesh also, we don't have the net metering policy by the DISCOMs there. So it becomes very important because so that we always produce the solar based upon the self-consumption requirement. So we have the solution for the grid feeding control also, or we can say that as a zero export controller as well. And then of course, because with this grid stability, it also becomes very important to have the modeling of the complete power system, also to have all the transient study as well, what all the losses are expected. So then we also do the iPLON, basically the power system simulation services also. At the moment, this is just for basically for our clients, where we provide our systems for the C&I segment and as well to the utility also, to meet the grid code requirements. Then the second statement is, because once you have the solar plant, once you have the renewable energy installed, so it becomes very important how you keep your plant operation and maintenance in an effective manner. So to have that, must be having the complete knowledge and the skill set to take care of your solar plant. So for that, we also have basically the global operations platform. So we are not only looking into the Indian assets as well, but there are some other assets in, for example, in Germany and in other Schengen countries also, and in USA also, where we look after those assets from the India itself. So basically in Mainapur now we have built it at 24/7 kind of, you can say that as a IGOP, we call it as a IGOP, basically the iPLON Global Operations Platform. It's basically the kind of, we take care of the renewable assets from the Chennai itself. So I'll elaborate you a bit more in detail later on what are the scopes into the IGOP. And then of course, when it comes for the point number 1 and 2, because to have the grid stability and to have the services and to handle the effective operation and maintenance, first of all, you must be having the access to the data, you must be having the access to the system also. So for that, basically, we have the IoT, edge and cloud computing solutions also. When it comes to the utility scale projects, we have the RTUs and SCADA solutions. And then of course, when it comes to the C&I and to the rooftops, we also have the data loggers and the weather sensors also. So basically, we make sure to process all the data from the field level and to so that we are sure about the quality of the data and the availability of all the devices on the field which is communicating to our system. And then of course, once we have this data, then we can make sure to have the effective operation and maintenance handling, and as well as the requirements for the grid stability as well. Yeah, so I'll start with the grid stability. So if we start with the utility scale PV plants, for example, in India, we have the CA guidelines for the project size above 10 megawatt. Let's say whenever the point of interconnection is above 33 kV voltage level, then we must be having the closed loop power control solution installed in the power plant to have the first time interconnection to the grid. So for that, basically we have the IGOT PPC, we called it as a iPLON Grid of Things power plant controller. So basically with this, we make sure to have all the power control modes required to meet the grid code requirements in a utility scale PV plants on a solar park, or to have the active power control, reactive power control, voltage based reactive control, and to have the frequency group control, ramp rate control. So all these power control modes we have basically tested and implemented the sites as well. So this power control, it's not only on a plant level, but we also have the possibility to scaling this down on a feeder level also, or on a plot level also, or based upon the individual inverter also. So with this IGOT PPC, we can also have an interface to the telemetry also over the IEC 104, so that in future SLDC or NRLDC, they can also give the control commands to the power plant So that's basically what's happening in Germany now with the Redispatch 2.0. For the plant size above 100 kilowatt, they want to have the control also to a power plant, so that they can also make sure the grid is stable whenever there are some bottlenecks. So with this IGOT PPC, of course, we also have the observability stacks, and we can also do a lot of things with this. We can provide the local workstations also and the cloud-based complete observability. So then we have also scaled down, because we have seen, for example, in Maharashtra, we don't need to have at the moment the complete full-fledged PPC controller installed for the older installations. So we have the flexibility to give the tailor-made solutions also. For example, if anyone having the issues during the night time, they're consuming the more reactive power. So we can provide the solution based upon their problem statement, where we make sure to generate the reactive power from the inverters during the night time, so that the power factor penalties can be minimized. Similarly, for feeder trip avoidance also, with the voltage and the reactive power has to be pumping or to consume based upon the voltage rise and dip. So that also we can make sure in that tailor-made versions also. So this is basically one of the sample architecture from a quick overview how this PPC is getting deployed to the site level. So if you see in this 200 megawatt project, we have basically the 4 different plots. In 50 megawatt plot, basically having the 2 feeders of 25 megawatt. So here if you see, we have on each feeder, we have installed a kind of a feedback energy meter. It's basically a PQM meter. And then we have on the left hand side, you can see these are the controllers from the iPLON. So basically we make sure based upon the feedback from this PQM meter to have the power control based upon like the point of interconnection what we are measuring there. So we make sure to control the active and reactive power control, what are the requirements at the time or at the scenario there. So this is basically more on the plot level, and if you see on the top also, we can also have the centralized control also on the plant level also, so that the plant operators, they can also basically access to have the complete plant level control also. And then of course we have also the interface to the SLDC also and to the forecasting agencies also, so that they can also forecast and schedule their power generations as well. So now basically scaling down the same technology or the same power control concept to the further commercial and industrial applications. So here in C&I, as I mentioned earlier, basically because in India we have seen quite often the diesel generators are involved as a backup source of power. So there we make sure to have the complete supply side management also and the demand side management also. So basically with this we have the complete integrated solutions, because for example I'll show you in this architecture. Here in this plant, we are having the 1500 kV of single genset, and we also have the steam turbine also as one of the power source also. So here basically we make sure the solar should be getting operated with the diesel generator also with the steam turbine as well, and as well on the same time it also makes sure when the grid is there, because this plant is installed in Uttar Pradesh. So they don't have the net metering permission there. So we also make sure to have the grid feeding control also at the same time whenever the grid is available. And then of course, if in future the batteries are also there, then we also have the flexibility to integrate our solution or to incorporate for the batteries as well. So this is basically one of the example of how in a plant where the batteries are involved, our solutions can be deployed. So basically, if you see in this plant, basically we also have the interface with the battery management unit also, with the bidirectional battery inverters, and we also have the operational panel control board also, so that not only the supply side, we can also do the demand side management also, based upon the availability of renewable energy or based upon the battery charge and discharge level. We can also ensure that tripping of the different load groups also. So they have defined the load groups here, the priority 1, priority 2, priority 3, or the non-essential load groups. So that can be also basically switch on and switch off. It can be isolated from the system based upon the battery charge and discharge level. Then of course we also have some standard solutions. This is basically the configuration based system, and this can be deployed on a simple rooftop applications when there is a requirement to have the grid feeding control. So, and of course this also complies with the VDE compliance also, which is basically in Germany for the medium voltage network to have the remote control of the plant. And then of course we also do have the possibility to bring all this data to a fleet management platform also, where you can basically completely automate your O&M workflows as well. So this is one of the sample architecture for a chiller export plant. So basically here we can install kind of a simple multifunction meter on the grid incomer or as well as on the load side also. So based upon the consumption requirement, then we make sure to generate the power in the same proportion. And then of course with the team which is sitting in the front, Rahul and Feroz, then we also make sure to have the power system simulations also with the PSCAD, and now they are also starting with Dixilent and with ETAP also in the future, with the collaboration with some other partners who are also present here. So with IGOP, with the global operations platform, you can see this is the team which is working. So right now we have around 15 team members which are working into the global operations platform. They will also present you later a bit more in detail what are the basically into the rooftops and in the C&I and the utility, what are the assignments they have. So I'll just make the quick overview. Basically in the rooftops right now we are managing around 1500 plants which are located in Germany. So basically we make sure to have the due diligence for them. So we have certain SLAs with the customer where we monitor their plant twice in a day, or in some cases once in a week also, or thrice in a week also. And then we have some standard reporting formats which we have to report to them, so that based upon our predictive and preventive analysis, they can also assign their resources to the site, basically to define the truck routes and to troubleshoot the issues also. Then in the C&I segment also, basically we also offer the AMC services for the preventive and breakdown maintenance. And then for our key customer base, we also make sure to have the proactive reportings for them to make sure the plant availability, and we also make the generation loss and the deep generation calculations and all the analysis for the load patterns also. Then in the utility scale side, we are managing right now more than 2 gigawatt, where we have installed our SCADA solutions and as well as the power control solutions. So we have the annual maintenance contracts with them so that we can ensure the plant availability on the higher side and the low failure rates for those sites. And the other good thing, we have basically the network of PV doctors, and which are basically locating nearby to the sites. So we have the concept of PV nurses and PV doctors. So basically the PV nurses are the one who are basically in the IGOP team. They are on the back end. They are looking after the health of the assets, and then they are giving report to the PV doctors which are basically on the site, and they go exactly on the site to pinpoint the issues and to troubleshoot the issues. So these are some picks from the IGOP, and then of course as a part of IGOP, then we also have the iPLON Academy, where time to time we organize some knowledge sharing sessions also, which are online and sometimes offline also, where we can have the specialized training programs based upon the specific group requirements as well. And then we have, of course, a lot of open space for the other engineering services also, which we will be expanding further in the future as well. So for observability solutions and for the RF solutions, as I mentioned earlier, it's also important to ensure the quality of the data what we are getting into the system, so that we can rely on the data what we have. And so having said that, we have completely the IoT based applications. We can offer the local SCADA as well, and the cloud based solutions also, and which is either on the utility scale projects, C&I also, and to the rooftops also. So, and have the flexibility for that all open source platform, and we can also exchange the data to the third party system via the OPC, REST API, and by the FTP also. And then we have the complete customized reports, preventive and predictive maintenance diagnosis, and all the ticketing systems also available. So these are the few examples of from one of the 30 megawatt projects where we have built the dashboards also for the site team and as well as for the HQ also. And this is also kind of a power flow diagram or the SLD where they can see all the field devices connected, all the HT side equipments also, what are their status and what are the important parameters available from them. Yeah, so thank you very much. This was just to give you a very quick walkthrough or overview about what basically solution products we are having at the moment for the Indian market and as well for the overseas market also. If any questions, you are more than welcome.
You showed some presentation on IoT for e-mobility, I think. Some 10th slide. What was that? Can you elaborate? Previous.
Okay. So basically, with this solution platform, we also have some certain make of charging stations, for example, the Kiba. So that system is compatible with this device. And you can also have the interface to that charging station also, and whenever you have the available or you have the surplus of PV power available, so it can basically make sure you can charge your car and you will be having basically the inputs, you are having the surplus power available and it's the optimum time to charge your car. So that possibility is there with this device functionality.
But the IoT devices, where you will be deploying, sir? Some is light to tell us how we are implementing it. Any idea?
Okay. You mean on the site level, how we are deploying? Can we just move to the next slide? Just come on. Next. So basically, for example, in this plant, this device is deployed on the site level, and there, if you see the interface for this device, we have the RS485 and the TCP/IP interfaces here. So all the field devices, whether it's a grid-tied inverter, it's a hybrid inverter, or there is an energy meter or weather sensors, based upon their respective protocol, they can be interfaced physically on this device, and then we make sure to have all the data processing from this. And from this device, we can have, for example, here we have mentioned Wi-Fi router, and we can process this data and we will push this data to our cloud server also. That's the flow.
So we don't make charging stations. So if you look at the charging stations, there will be different types of cables and connectors and all that kind of stuff. And there's all the earthing falls and all those things will be there. And there'll be also microcontroller communication unit there. We talk to that unit. So we give information from this, hey, there's no lot of energy available, why don't you use it? So if they have also different kind of tariffs and all that, we can do that. So we talk to a lot of different types of charging stations, but we don't make them. Yeah.
Any other questions? We are using, say, third-party RMS solutions, not just iPLON, solar alone, any third-party devices. When you are using it, common problem what we face is inverter firmware update. Say most of the inverter problems, 6 months or up to 1 year, most of the problems whatever we face it in the inverter, which will solve when we update the firmwares. Communication issue or inverter errors, what error logs, whatever we have to get it regularly. So those errors will get rectified when we will have proper data from the inverter when we ever let the firmware. How we are going to address the firmware update with respect to, because when I go with inverter manufacturers, same platform, they are giving inbuilt solution. So I mean, their engineer can remotely update the plumber, or we can update the plumber from the site. I mean, sitting in office. When I deploy a solar log or iPLON, so how I can do it? I mean, what's the solution? This is, I would say, a good question, because it's quite often we also face the challenges sometimes, but at the same time, it's very important we have the close network or the close communication with the inverter companies. For example, with the solar log, with the iPLON solution, because we have the direct time-to-time communication with the inverter manufacturers also, and we make sure to basically to keep ourselves also up to date, because it's a part of kind of a checklist whenever we makes a commissioning or we makes a system installed. So we also make sure what are the firmware versions on the device level also, and it has to be always on the latest available or latest recommended firmware from the original equipment. So that's the basically a kind of a must criteria, because we always ensure from our side also it should be always the latest firmware, and then of course fields devices as well, it should be always the latest firmware available. And then of course if something goes wrong, then we needs to jointly address to the inverter manufacturers also to get the solution or to get the beta firmware for that. Can you give us that? I am asking that. You have to hide your light. Say rights to update because you need rights to update the firmware. That is one of the you are putting your own third party permission to read, not to comment or maybe comment to control the generation to formatter or load control and all those things. What permission you doing with this form problem? You can answer. Basic control. Whether you allow to update the firmware.
We can support customers like having old firmwares, so we can take a remote support. We can act as a bridge between the customers and inverter support team. So some inverters are old, it's not compatible with a very new update of firmware, but we can able to check which firmware is compatible for this power control operation, and we can able to communicate with the support team of inverter manufacturer, and we can able to do the firmware. Yeah, most 10 inverters, 10 inverter companies we can able to get touch with them and we can able to support.
Once power update is happened, then we have to deal with it. Now the next inverters are offering with say medium grid utility voltage down. People is going to certain level. The same alarm and getting old. Is giving me benefit of say where they have to change the reasoning to any has to get into it. So when I deploy third party solution, it's not just deploy alone. So we have this a common problem. Then when problem comes, then I have to fight with it. Yes, I have to deploy. So after getting a problem, I have to look for what I'm asking is there any solution? So like you find it so that whenever it is there, so you can inform us so these updates come to these leaders want to install it.
Why don't we work together and make a internet forum so that everyone who has the same problem, he can put their problems there, because the solution is easy. Yeah. So, exactly. Because it's such a small problem, but if two egos come and say, I don't want to do this, then we will suffer. So the best thing would be if you have a forum, and whenever you have an upgrade and mistake on that, so we will benefit, we will enjoy it. Yeah? So let's team up with other companies who have a similar problem, and start a small, inverter association or something, and start using it. It will help everyone.
Any pilot quality of your work, how you are monitoring what data transfer.
Okay.
That would be really helpful because the field engineers knows better. Academicians can just visualizing what is going to happen.
I think what we will definitely do is, these are young, very strong people. So actually we are trying to demonstrate all that, but it's not so much of time. So what we can do is send a small team to Anna University or HIT or other universities, and they'll take half a day or whatever the time it needs, and they'll sit down with the team and demonstrate it. Done. Done.
Sir, actually, being from the computer science and engineering background, so I would like to know more about the cloud computing solutions. So what you provide with your iPLON. So it has been integrated with this. So whether will it give you advantage on load balancing and the fault tolerance? So apart from the analytics and data logging, so will it also do, for example, so there will be so many panels. So the electrical background, people may know. So it may have so many panels, so many batteries. So how it will help in load balancing? So can you throw some more light on?
We are using Google Cloud platform as a cloud for all the data and doing all the analytics. So we are using this Google Cloud platform to store data and doing all the analytics and all the calculation for these devices and at all site people's want, so we can do that Google Cloud platform only. And apart from that, like load balancing and all, we are using only one single ingress control, and which can take a bandwidth like I'm not sure about bandwidth, but right now it is coming. Hundreds of plants I get controller data directly into that Google Cloud itself. So a single load balancer only, but it can take more than 500 devices, I guess. So so there is no issues yet we are facing in load balancing stuff. And like protocols we are using like it's secure HTTPS protocol only. So that's all.
We are using this Kubernetes Docker, this kind of architecture in the cloud and the microservices.
So the big advantage of this microservices, you can have to scale up the number of microservices. And because we have also this cloud to cloud computing, so we can also run, let's say, Kubernetes containers in Google Cloud and also in Azure and all. So that way we have a very good scalability. And this IoT devices, they can also send to 2 different clouds. So that way also we have the capability for this load balancing what you mentioned. And it's not just the cloud, we also have an iPLON Chennai office, also a lot of NEC-based computers which we can also use as a kind of Kubernetes cluster. And we have also these servers, some sitting in Germany, some in Chennai, Hyderabad. In Mumbai, yeah. So that and the cyber security, everything around it. So that's a very important topic for us, because otherwise companies in Europe and all that will not trust us. Yeah. So we have that. Yes. So we have basically one Strato system in Germany, on this GoDaddy system in USA, and Google Cloud in Mumbai. Yeah, and they also at least have given us the certification that Google Cloud is also backing up in some other place, so that if there's a fire in one place, the other place will work. So those kind of certificates we have from them. Yes, thank you. Any other open questions, or shall we move to the next topic?
One question, like, talk about forecast rate. Is it forecast for wind or what voltage?
That is basically the power forecasting. So it's basically for the solar power plant. Yes.
Battery storage system, you are also providing the service.
We don't provide the battery storage systems, but of course, if you have the battery system available, so we can have the interface to the BMU, and we can also fetch the data, and we can also visualize the data to our platform also.
Battery rating, not this parameter what is it?
Oh, we need to have the interface. So whether we have the RS485 or the TCP/IP interface available on the BMU, and then we can once we have the Modbus mapping available,
So
we
I'm
can.
not talking about the communication sector.
Yeah.
The battery capacity is decided based on the load requirement or the inverter capacity.
Battery capacity, of course, it has to be decided based upon the load requirement also, and then you have to deploy the bidirectional inverter suitable to your battery ratings also accordingly.
Sir, actually, I am from Integral Coach Factory, Indian Railways. In our campus, we have installed around 3 megawatt solar plant.
Okay.
Only on Sundays, we are exporting around 6,000 megawatt to 6,000 units to TNB grid. Because it is actually not in the net metering, so we are not get paid. So for Sunday only we have to store the energy. So we have to concentrate on how much energy exported on Sunday. Based on that, we are able to make a storage system.
Yeah, then based upon the surplus power we are having, so that system then accordingly has to be designed. So, but to be honest, we are right now we are not into basically designing the system and giving you the system installed, but we have the right partners which we can also cooperate with you, and we can come together and we can discuss on your problem statement, and we can make a design of the system also. Any other questions?
Sir, we are talking about monitoring the system. Each system has got maybe in a remote place. We are able to monitor it. If there is any problem, we were talking about nurses and doctors. If there is any problem, we have to get the message immediately so that we can do the.
Yes.
But we don't know how much power we
That power control, it's possible. That can be also, that's also basically the part of this. So we can also have we can also request how much power is required, and we can also deploy the remote commands also. Basically, how much power we needs to curtail, or how much exactly the parameters needs to be set.
My question is, sir, suppose we are talking about the right?
Yes.
So we will not be able to get excess power always because of the weather conditions. So to understand that yes, the power is not it is not expected. Will you be able to communicate to the grid, or how you are going to handle that?
See, for that normally, when it comes to the utility scale projects, normally we have basically there are some forecasting agencies who are basically giving this schedule to the TSO and DSO. So for that, basically we send them the data on the formats they require. For example, on a 15-minute interval, we give them data, and then they basically do the forecasting and scheduling to the TSO and DSO further. But we have the direct interface to those forecasting agencies from our system. Okay, thank you very much.
So the next presentation will be from Mr. Peter. So he will be describing the Stadtwerke as a robust and process-driven multi-utility company concepts. So I'll just play the video first.
Between generation and consumption at all. There needs to be a balance between generation and consumption at all times to ensure a reliable power supply. This is a key function of all European network operators that need to remain stable at 50 Hz. Fluctuating feed-ins from 1.7 million units generating renewable energy in Germany alone, such as wind turbines and photovoltaic panels, require close cooperation between all network levels. With sun in Baden-Württemberg. Plenty of electricity is generated from renewables, thanks to good weather, plenty of wind and lots of sun. Hardly any energy is consumed, as many people and businesses are on holiday. Targeted interventions in generation may be needed to prevent this from resulting in an imbalance between high generation levels and low consumption. That which is currently coordinated by telephone and email will be semi-automated in future, guaranteeing a dynamic, quick and secure exchange of data and information between control centers. The system balance, in other words the balancing of generation and consumption, is monitored in the main control center of the transmission system operator, Transnet BW. If far too much electricity is being generated, the system sounds the alarm. The network status traffic light then changes from yellow to red. The action request to reduce generation is in the pipeline. The system management engineers launch what is known as the cascade. There are just a few minutes left to reduce the supply. The request to reduce generation levels is received by the control center of BW Networks. It has been given an advance warning by the traffic light. Employees check which units in their high voltage network can be scaled back. More than 90 downstream network operators are involved in this process. The request to take action is then received by the municipal utilities of Schwäbisch Hall, which operate the medium and low voltage network in the area of Schwäbisch Hall. Units are automatically selected in a program that calculates network security 24 hours a day. The network control system reviews the outcome of the intervention. Employees then enable the process and shut the units down. As less electricity is now being generated after this reduction, the system balance has been restored. Electricity supply is guaranteed on the basis of close cooperation between network operators.
So, thanks. Now me again. So next, I want to show you something about system control Schwäbisch Hall. In the next step, in the next slide, I think we can. Next slide. Okay, we can go to the next slide. You know me. Okay, the topic is monitoring of grids, efficiency of grids, influence of redispatch, and awareness system. Okay. So, the next slide. So, forecast for the total next 36 hours. This is the grid consumption from the grid Schwäbisch Hall, around about 60 megawatt, and too much energy is generated. So we send energy to the DSO. Back. Okay. Sorry. We send energy to the DSO level 1 NetzWW back. It's around about 40 megawatt. And I think in this February the highest term was around about 80 megawatt. And I think next year we install the next wind farms in near Schwäbisch Hall. And so round about 100 megawatt wind farm is coming. Now the total consumption Schwäbisch Hall is around about maximum 70 megawatt, and the income from wind farm, photovoltaic power plant, CHP and so on is around about 175 megawatt, and 100 megawatt are we plan to install 100 megawatt wind farms next 2 years. So I think we get sometimes problem. We need Redispatch 2.0 to get the grid stable. In the next slide, you can see traffic lights. Traffic lights. Traffic lights are in all substations we have traffic lights. When something happens in the low voltage grid, traffic light is going on from green to yellow to red. The traffic light was a special thing created by iPLON. For all the grids, iPLON makes a business for Stadtwerke Schwäbisch Hall. They install all traffic light in all pictures, in all network plans. It was not so easy. iPLON is far away from Germany, secure and so on. We have a lot of discussion, but now it works. We have in all substations traffic lights, so we can inform the workers who are working in the low voltage grid. Something happens, please go out and solve the problem. In this case, you saw the online calculation. Now the power flow is going from this substation to the next substation. You can show 1.3 MVA is going to Udenhofen, to the next station also. The dispatcher, I can show you it in the online session. Dispatcher knows all, and all second we get a new information about the grid, and the forecast is spoke in the morning about it 36 hours. When something happens, separate line is going on and shows the dispatching team some feeder is get to more power and perhaps in this evening or what else, so they can get start a reaction about it. In the next slide, the substation Stumpfegger, the traffic lights are green, nothing happens. Okay, in the next slide, it's very, very interesting, I think, for you. We have a separate system for the low voltage grid. Low voltage grid is database by GIS, and we get information from data from the meters. In German we call it Energy Data Management System. So we get all information about it. We send to the low voltage grid system the information about the power, the voltage, and so on, and we get the traffic light information for the traffic light back. And for the workers, for the technical men in the low voltage grid, it's very important that they get some people informed. We want to install a PV power plant, we want to install a charging station, and so on, so they can test it online and they can say, yes, you can do it, or no, we get a problem in the low voltage grid. So the workers from the low voltage grids are happy, they have all information, and I think it was one of the first systems in Germany who have done this. I'm very proud, it runs now, and so I think in the future all DSO needs a system like this. So in the next slide, it's the same. The way to calculate e-mobility, it's the same challenge. In Germany, I think around about 8 or 10 million electrical cars, and they want to change it to 100% in the next 20 years. Okay, in the next slide, solution for grids. We talk about in the morning about frequency stabilization, transmission, data transmission from one TSO to the next DSO, and so on. Yes, we have a high number of volatile feeders, and when we get a problem, system split, I think it's possible in 10 years, we get a system split by the DSO, and we must back synchronize to the DSO level 1. So, in the next slide, we talked about it in the morning. I think it's clear. Now, the next slide. Yeah, it's Redispatch 2.0. Fast 100% goes automatically. Nothing. No dispatcher must help the system. No dispatcher must go to the phone. No email. Nothing else. When something happens in the power plant, the information goes from the grid system to RAIDA, to DARE, and in the web client, same as iPLON. All users have web client, so they can show what happens with their power plant. And they get the information via SMS, via email from a system in the control room Schwäbisch Hall. So I think in this case all processes must be automatically normally. The dispatcher only have a look inside when some problem is. But normally it runs. Okay, the next slide. It's important. I think 3 years before, 5 years before, we get emails when the TSO or DSO level 1 get a problem. We get emails. We call it sneaker interface. We show it. The shoes are burning. We get an email. We must print the mail. They told us, please shut down this 5 megawatt, and so we must sign it, send it back. It was impossible. And we discussed many years about the system, and now in the next slide we can see what we have done. The transmission operating center we saw in the film is connected with a private line to NetCBW. And NetCBW is connected via satellite to Stadtwerke Schwäbisch Hall. All information from the grid is going over this way. It's a blackout secure way. When something happens, the open infrastructure, GSM, what else is not running, so we can get informations and send informations to the grid control NetCBW. In the next slide we say what we have done. It's totally easy. We use remote terminal unit only, so those companies have a great knowledge about it. So we talk with the information runs with 2 RTUs, and I think it runs the last 3 years. That falls from, I think, 10 seconds, not more. Okay, the next slide. We saw the information. All lights are green. All lights are green. The grid is stable. When something happens and the light is going on, so reaction starts in the grid control room Schwäbisch Hall. And the same. Look here, the same when we have a problem in Schwäbisch Hall, so we can inform about the system, what happens in Schwäbisch Hall. We did not need telephone, emails or what else. And here on this side is a show about the renewable energy, about the CHP per 110 to 20 kilowatt transformer. And the DSO level 1 knows all what happened in Schwäbisch Hall. This was the main topic of this, and we have done it with all DSO level 1 in Germany. We make our business for in the morning for 35 DSO in Germany, so we have done it with all DSO level 1. In the next slide, we saw TACA. TACA, it's a name from the system. Before I show you, we get the information about email now. They send information, Ankündigung in German. They send the information, something happens, you have to help us. they send at next, they send information, please go down or go up with 10 megawatt. And then we confirm it, so they know what we have done. And so, and at next, when the system is stable, we get the information Tag 1, and we get a request, okay, we understood Tag 1. This is a system we have done with, I think, with all DSO level 1 since the last year, and now it's a rule in Germany, all DSO level 2 have to need a system like this. We tested in CSAT, it's a great project from the government, and we told the government the system runs now. We can start with a rollout for whole Germany. It's the next slide. Yeah, this is also, here I want to show you different grid systems. Grid system from the Transnet BW Siemens, grid system from Netze BW PSI, also PSI, and we use Vivavis, before it called IDS, and the low voltage grid. And the communication is via satellite. It's really good thing, I think. So we are flat out secure, and when something happens, we can talk about the system. Okay, the next slide. Training system. It's very important. I heard it from iPLON. They have also training systems to learn something about the grid. When we get a new grid operator, engineer, girl, women or boy, they normally spend 2 weeks in the grid simulator. The trainer can place all faults into the system, all faults from the last years, place into the system, earth fault, short circuit, what else, and it's the same data as in the grid system. In the next slide, so it's low resistance, star grounding, earth fault, short circuits, phase shift operation, we discussed it in the morning, so we can prove what happens when we get too much power from wind farms or photovoltaic power plants, when we make a phase shift operation, switch on, rush, blackout, we can make a training session, and also it's possible to make a training session via video. The customer or the partners from us, the power companies in the north, normally use a web session to get training in this system. Okay, the next thing, now we are ready. It was a short presentation, and I hope you have many questions. Thanks. Okay.
So I'll translate his German to Tamil. So what basically he's shown is that you don't need big companies like Siemens, Alstom, GI and all that. They've been there for many years. So there's a revolution going on in the background where smaller companies like Stadtwerke Schwäbisch Hall, iPLON, IoT and these kind of companies are coming up, and they are biting these big Siemens, Alstom and all these kind of companies. Anyone from Siemens here? So this whole scenario has got to change into decent. It cannot happen that you have big these companies, it will not work. Yeah, it might work in big cities, but if you go down to the rural areas and all that kind of thing, this will never work. So what he's done, he spent 40 years of his life working with smaller companies in Germany and building a system together, which is basically showing here. Yeah, so it's got nothing to do with Siemens, it's got nothing to do with Alstom and all these big companies. It is a system built for him. So he has designed it, he has got other smaller companies work together. Yeah, and it basically does a model of the complete electrical grid. So if you look at Mylapore, so you have Dr. Radhakrishna who does a big substation. So how that is that substation model, yeah, and converting that electrical model into a software model, yeah, and then all the cables getting out of the substation and going to Lust Avenue and Malapur and all that kind of areas. So every cable, every VCP control box, every distribution box, everything has got to be modeled in very clear detail. So once you have that model, then if there's monsoon and there's some short circuit in one part, yeah, so what this system can do, it can switch off only that house or that one street, and it will get electricity from the other side. Yeah. So today what happens in Mylapur, if there's a monsoon, there's something, switch off the whole street, nothing, you know, and they'll wait for 2 hours or 5 hours, and yeah, someone will come, will check and all that. You know. We are going through all these things, and this is physics and mathematics. Yeah. So it shows exactly what is the problem and where. So that's one big advantage the system has built. Yeah. So when you have a power cut, it's not that there's not enough energy. There is energy, but because the system has been not well designed, one VCP has tripped, and that's why we are all facing this problem. Yeah. So that's one. The second big thing, what we both feel that if we don't make it decentral, a lot of this renewable energy which will keep coming in the future, yeah, they will clip the transformers, the 10 kV transformers, which you go outside and look at the big transformers, yeah. So they say this overloading and all that, we cannot give you permission to give this put more PV plants. So the whole renewable energy will go down, yeah, and that is actually our biggest fear, that because of some incompetency and very old systems, the Siemens and all that, the renewable energy will not come up. And the renewable energy doesn't come up, also there's battery charging stations and all these things. Yeah? So then, of course, you could need, again, like someone was saying, that now 400 megawatts of more thermal power is needed. You put more nuclear plants and all that kind of stuff. You know? So this is a big, actually, change of philosophy, getting out of the fossil energy and getting to renewable, and with this getting into decentral systems. So that's actually the basic bigger points, and what he's actually tried to show you, that he has done that in Germany. Yeah, and this afternoon also he'll be showing how all these things work online. Yeah. So good translation.
Very good, Sid.
Appreciate Peter for fantastic work which he did, and for it is presently we can able to implement in our system, because we all know about our system, how far it is there. There is a lot of challenges are there because we can't compare the Germany and our system. So totally we are.
After lunch, we should all go to attention and after we go out, go for dinner. It's just us. That's why it's called citizen electricity.
Yes, yes.
Yeah. So we have the power to do it if we don't. But the technology and the knowledge, yes, and all these things is there. So the universities, the children, go and protest, say, I want 24/7 electricity. So it's to the income.
Inmate units, transformers, they're going for inmate units.
They're going for what?
Inmate units.
Did you? Okay.
They're doing that. And they say that it's because you need to identify the location of the fault. And you cannot cut the power or something. That particular transformer will be deworked or something. And you rightly pointed out the problem in Germany is also the low voltage network. Same thing is our Tamil Nadu state also. We have another main thing. You have to stop or clear the drainages and also cut the lines. The EPs also take part of it. So how, as he said, my doctor just told, it's a densely populated state of Tamil Nadu because we have planned the city. Whereas Germany is, I think it should be planning is Germany. 40 years over the 40 years, how the decentralization can be embedded here, and how we will be as as academicians, what should be our role? So that we form the curriculum, and you are aware now, our vice chancellor is having ambitious plans to make it industry oriented, etc., etc. But I just want to at least make something which I can teach to my master's student.
Feroz has made a drawing, a strategy for Mylapore. So he has picked out where the different transformers are there and where the cable distribution box where we are staying. Yeah? So it will be helpful if you pick up that, and also we can then talk to the Professor Velraj and also to the TNP, and let's see how we can start one small system there as a proof of concept.
Because whatever he says, we could not take it in our minds. That is the only thing. The emulation is not, actually I'm not getting it. So that once I get it, I can transfer to students.
Yeah. So,
but I feel that Mr. Peter have done a lot of hard efforts. But
40 years, he's taking 40 years, I don't know why so long, we take only 5 years because we're smarter.
Again, one more thing, ours is a developing country.
Yeah.
So still we need to do a lot of efforts to take it forward.
But we have more people.
More people, but what to do? No, nothing is materialized. More people, only this is happening.
Education, education, education.
So, next presentation will be regarding the networking. So, from morning you could have listened the word like networking. So, what is networking in iPLON perspective? So that strategies will be explained by Srinath, HR and strategies. So, he will be explaining the Indo-German Cooperation Forum and also the university, Gandhigam University lead like Dr. Kirubakaran, Director and HOD, Gandhigam Rural will be presenting this demo through virtual. So, Srinath, you can take over.
Good afternoon, everybody. So, after my presentation, definitely it's lunch. So, I will quickly wind it off. Yes, so iPLON, if you see, one is technology and second important part is cooperation and networking. How to build the cooperation and networking between all the German companies, how to bring them to Tamil Nadu, and what are the skill set available in Tamil Nadu, and how to have a e-silk route from Chennai to from Mylapore to Germany. So have a lot of trade happening between Chennai and Germany. So that is the main idea. Yes, next. So iPLON, if you see, it's about connections. How many people have shown up today? It's a very happy to see that, and how to bring these connections together and how we have to help each other and grow faster. So that is the important strategy. So as I said, we are trying to have a German Intersolar Germany in to have a Tamil Nadu pavilion. How to have right people, what are the services needed for Germany, how to have all that and show what is capable from the Indian perspective. So that is one important perspective. Then networking with universities. Now we are collaborating with Hindustan University, Anna University, Gandhigam University. We are already doing, and how to have this student exchange and all the programs possible. Peter is also a visiting professor in University of Heilbronn. So all that strategies and how we can help each other and more research and development activities can be happening between Chennai and Germany. So, and also we have a lot of cooperation companies. We have a lot of MOUs signed with different specialized companies, so that who are specialized in that pool, we have to take them and we have to bring a cluster. Like in Germany, we have solar cluster. Like in India also, we are trying to develop a cluster of companies who can help each other and specialized in different domains. So last month we also did a workshop in Coimbatore. So this series of workshops also Victor will explain the strategy. So this is the MOU signed with Gandhigam this year. So we are also visiting tomorrow Peter and Victor to Gandhigam, and we are also trying to model the whole Stadtwerke he is explained for a big city. So how to have a model for a university and how to break it down for a department, how to have a complete Stadtwerke control system for power, waste, water management, electromobility. So that how to have a co-design, so that we are planning. There is also 2 megawatt plan there also in this end of financial year we are starting. So how to have a lot of idea and strategies for that. So that will be we are discussing. And Hindustan University also we are working very closely. We went there, my AAA department, and 2 people have joined also. So we have working very closely. A lot of people working now from computer science and AAA department. Because if you see iPLON is not an electrical company, not a computer company. A lot of different streams comes together and have to bring out a solution. So that is very interesting. So in that way, it's very positive. So more projects are happening between Hindustan and iPLON. More students are doing projects in cyber security, big data. So that helps us. So we will be visiting the university also in November. And 2 months back, a lot of students also came to the office for industrial visit. So further research possibilities are also we are exploring. And with Anna University also we are just starting from this year. With Taros and Rahul joining, and a lot of professors also coming, and we have to work closely so that finally the students also gets benefited. So this how to have more collaboration between the German and Indian universities. There we will have a different discussion with Peter, because he also have a lot of German contacts. We will also have how to have that mutual exchange programs, and the professors from our universities go to Germany and do there some research. Yeah. So different government agencies also we have to bring into the network, because they are also decision maker and they also help us in different ways. So we are trying today to have some people from these different companies, and it have been seen that this helps the whole network part have to come and it should click, and it's like a neural network in the brain. Each body have to function things. There is a different complete information exchange happen. So we also did a good job in Pavagada, how to have the whole 2000 megawatt of plants with different making it as a cluster for different technologies bringing. We brought the drone technology, we brought the artificial intelligence technology. Different companies, around 10 companies came and we did some good projects. And finally, we also have signed with some cooperations with different oil and gas company, because they are trying to improving the generation. So we are having different specialist companies. We have separate cooperation agreements with them. We are also working very closely to have different specialist solutions for the specific industry. Yes, thanks. Now from Gandhigram, Professor Krubagaran will join online, and he will show what we have did till now and what are the next strategies. Then we'll go for lunch.
Hello sir, can you hear us? Hello, good afternoon sir.
Can you hear me what?
Yes sir, we can hear you. So thank you for joining us live. So you can start the presentation sir. Sir, am I audible?
Yes.
Okay.
Okay. Whether my screen is visible?
Yes, sir, it's visible.
Can I start?
Yes, sir, you can start.
First of all, it's a thank Peter and Mr. Victor for giving me an opportunity. I think it is a hard time, okay? So I don't want to go and tell you so much, so I want to put my presentation. Okay, let me brief. What is agenda is about our GRI, okay? How we are implementing this roadmap, okay, for Stadtwerke Schwäbisch, okay? Because the law, I think the agenda is whether we can bring the German technology to India. Can we do that in our campus? That is our objective. Okay, we work on the global goal, okay, the sustainable development goal 6, goal 7, goal 11, goal 13 and 17. Okay, if you see, we want to have a clean water and sanitation, clean energy, sustainable cities, climate action, and the preparedness for the growth. A small introduction about our Gandhigram Institute, because many of you may not aware of this. Okay, it is one of the rural in southern part of the India, which is governed by Government of India through Ministry of Education. We have 207 acres land. Okay, because near Benirkal, we have 15 departments starting from Tamil, Hindi, Malayalam, English, French, as well as we have all science departments, all arts department, all management department, including engineering. We have a roughly student strength of 4,200. Okay, we have our own campus, we have the hostel buildings, we have quarters, we have guest house. So if you look out, this is a one, say a small area where you can find out the various things. Okay, building is there, quarters is there, commercial complex is there. Okay. So what are all our focus area? We have energy management, we have water management, we have waste management, we are planning for e-mobility. So all these things to lead for the sustainable campus. In the present situation in water management, we have overhead tank, from that we have distribution. In the renewable energy, we have a small solar power plant, okay, which will partially replace our requirements of electricity. We have a e-mobility, we developed our own auto, and we purchase e-bus for mobility of the disabled students. Coming to waste management, we are having a small biogas, 25 cubic meter biogas plant, which will partially replace the LPG requirement of the hospital. This is our energy sector distribution. Okay, if you see, this is like a small town. Okay, we have a department spreading around 200 acres throughout the. Okay, we have departments, we have quarters, we have hostels, we have a commercial complex, everything. Okay, this is our distribution network. Okay, the present distribution network is this. We have DTs. Okay, these DTs we are fed from the main substation. Okay, 22 kV. Okay, this is we have commercial buildings. I think energy sector in domestic as well as government. Government in the sense we are called as departments. Okay, this is the power supply which is observed by this project, the feasibility study project through iPLON and Mr. Peter's support. We observed the power consumption throughout here. Okay, what are all the interruptions in the power supply during the non-availability of the grid? Okay, this is the weekly load profile from one particular transformer where we are installed the device which we get from the iPLON, and we analyze what is the load profile of that particular DT. Okay, this is the water distribution network. We have a borewells, we have a sump, we have a now Kaveri water sump is coming. So all these locations, from this water is collected and distributed to the departments. This is the weekly water consumptions. Okay, roughly we are consuming to 3,20,000 liters per day. Okay, this is the area. Okay, wise distribution of the water. Okay, then water like waste management. We as a university we could made a very preferred plan for the waste management. We have a 3-bin system. All the waste are regularly every day it is collected and is segregated. The segregated waste are spreaded in the landfill for composting the waste. Okay, these people are involved to segregate, and that compost waste can be used as a fertilizer for our agriculture land. Okay, so we have waste management. We installed a 25 cubic meter biogas plant in the year 2018 in the ladies hostel. Okay, from that we monitored, okay, through a flow meter, what is the unit of gas generated, so that we can arrive at a conclusion. Okay, we can partially replace 1.5 cylinder per day from the biogas plant. The slurry which is coming from the biogas plant is taken through the tankers that can be used as a substitute in the composting yard, so that the earlier the compost yard requires minimum 15 days. Because of the slurry, we can able to get 7 days of the compost. That compost has highly nutritious that can be used, that is used in our farm yards. Okay, this is a complete waste management practice we follow. Coming to the mobility, okay, we have regular 2-wheelers, 4-wheelers. So what is the outcomes of intervention of the iPLON and as well as our team? Okay, we completely carried out this study, and based on that we analyzed the grouping of services. Okay, we divide these entire campus, that is I have shown one figure. We have taken entire campus into 4 divisions and grouping all services, which is need 12 lakhs per year, and we can retrofit all street lights with LEDs. We are getting 1.1 lakh per year. This is the main outcome we got. Okay, if you see this graph, you can understand what is the outcome of our feasibility report. If you look at the 2016, our demand is rising. The energy unit is rising. Our EB payment is 80 lakhs per year. Now we are, because of these interventions of salary, we are bringing down now to 55 lakhs per year. So this is the main output. Per unit of energy cost, we are bringing back from 8.2 to 6.8. So this is the main outcome of our study. What we, I think, thanks to iPLON also. Okay, this is the energy savings what we have done in street lighting. Okay, what is our future energy planning? Okay, we are having now almost optimization of existing system is over. We are now going for the MV distribution system. Okay, the modernization of all, the electrical energy distribution with a new transmission station. Okay, because we have a recent substation installed by the time that goes, so we have to redesign everything. All cables and underground, we are planning for underground cable. So how we can go for this? I think with the support of Peter, okay, we have planned for the MX software for optimizing this. Okay, what is our expansion stage? We want 24/7 power supply. We want reliable, because now we don't have questions on reliability, because sometimes we have power quality issues, sometimes low voltage, sometimes harmonics, all these things are there. So we want a reliable power supply. We want to have a zero emission. Okay, we are planning for electromobility alone instead, but we are planning for complete stoppage of conventional vehicles inside the campus. We have a charging infrastructure and e-mobilities. Okay, this is already had the plan, okay, how we can do for this future, okay. This is a mobility, that is mobile fiber optics, MV line, LV line, heat and cooling grids, water, shower waters, waste water and green water. Okay, all these things are underground. Okay, we are planning for photovoltaics, we are planning for battery storage. Okay, we are dedicated for lights for street lighting of all our street, all the telecommunication lines also modernized, to be modernized. So we are planning for recycling of water, okay, and reusage, okay, so that water usage should be minimized and optimized, okay. So coming back to the electromobility, we have a plan for 3 cars, vans and 1 bus, 1 tractor, because tractor is essential for our distribution of this biogas digester slurry and other waste waters. So we have planning for rental scooters at the beginning. Okay, charging stations will be provided with the LED street lighting. Okay, number of PV equipped. Okay, what we plan. Okay, I think with the support of iPLON, they planned is administrative building 5 kilowatts, canteen 10 kilowatts, entrance 15 kilowatts. Okay, this space management we are planning for. We are having biogas plant. We want to have a combined heat and power plant with the help of biogas. So we have heat storage with the heating and cooling requirement. We have absorption chillers, so that, and we are working on biogas fuel cell also. Okay, that is our future goal. So what we have motive, okay, to showcase how the distribution of multi-utility grids, okay, which is there in German, can be applicable at the GRI campus. That is our objective. What initially when Victor and Peter is here, they told they have their German, what is the technology is there, how they are managing. So can we bring all these things to our campus so that we can claim ours is a unique campus having a multi-utility companies. Okay, I think this Twitter has shown this. I think this multi-utility company at German, how they are working. Okay, success is easier to achieve when all are in one side. Okay, that means entire thing is managed by one side, so it is we can achieve. Okay, why we have proposed Stadtwerke Gandhigram? Because it is a decentralized thinking, or decentralized power generation, decentralized mobility, decentralized water management. What Gandhi is envisaged. Okay, Gandhi wants a decentralized power. Okay, that means decentralized energy will be the future. Okay, if you want to go for any energy independence, we have to decentralize it. It will be leads for the greater success. So that is the motivation we have. We want to work on Gandhian principle to make a power sector also decentralized. Okay, these are all the messages made by Victor and Peter, and continuous. I think they are planning next coming Friday also to be here. So with their support, what we did, I have presented. Okay, I think we have the MOU with them. I think regularly they are motivated our students. Okay, because it is a new concept, we can work from the bottom approach. Okay, not from the top down approach. From the bottom up approach will make real success. Okay, this is the stage 1 we are planning right now. Okay, now we are feasibility is over. We are going for implementation phase. We plan for a 2 megawatt plant with the grid connected facilities. We are planning for charging station. We have additional storage for batteries, and the stage 2 what we are planning for again water management, and stage 4, 3 and 4 we are planning for the heating and cooling techniques. Okay, this is the proposed plan coming immediate action for solar and EV charging, batteries and other heating cooling in the next phase. Okay, I think I am not exceeding my time. Okay, thank you very much. Thank you for your patience. Thank you.
Did iPLON do this, or who is confusing iPLON with some other company?
iPLON has done.
Yeah. So thank you very much, sir.
Thank you, Victor.
Okay, thank you, sir. Thank you for your valuable presentation. So So it ends the formal session. So now we'll be having the lunch session. So I request some of them to go to lunch. So whoever want to interact with Peter and Victor, they can stay here, and remaining people can have the lunch and come as soon as possible, as we will be starting the live demo sessions by exactly 2:20. So I request all you to be assembled here by 2:20. Thank you. Later.
It is top voltage in Germany, which are mainly a low and middle voltage in watt. Then you can calculate it. In the past time, we had a woman
normally in 2 or 3 minutes, and so most people are this case on power only. I think 100 people have to wait for the workers. Okay, Tino?
Yes, perhaps the fault could be on the line between 34 and 33.
Yes, okay. Switch it out. And
yes, no.
Okay.
The guy switched it outside.
Okay.
And it's possible to get the power from Pfitznerweg 38.
Okay. Switch it on.
Switch that.
Normally only 5 minutes. Only 5 minutes. All people are electricity is in service for all the people. Only the people, and I think who lives near the station, power substation, sorry, Gewerbeschule, they have to wait. Some workers coming out, and normally they solve the problem. The outages in Germany in this grid are under control from the power system Schwäbisch Hall. Normally we need half an hour, so all people are under power, and the outages were very small. We have not more than 7 outage per grid and year, not more. I think 10 minutes for all people. Okay, Tilo, so?
Yes, and if you know that the fault is here, you can switch it off on both sides.
Yes.
And turn this switch on again.
Yeah.
So everyone has electrical power.
Yeah.
Again.
In this case, the digger is driving out, goes down, and the worker are coming, make a new move, and then they are all, the system runs. Okay, Tino, thanks. Now we go to the next. What was the next topic? Reactive Victor, we have a problem in Schwäbisch Hall. Your wife have to.
I can show it. I can show the problem.
Your wife have to use a hairdryer. We have no wind today. Okay, this is a wind farm, Kohlenstraße. Normally we have 23 megawatt. But now today 600 kilowatt. Yeah, we have no wind in Schwäbisch Hall today. Tino, what about sun? Can you show us a PV power plant near my house?
Yes, I look for it for a moment.
In this case, we want to show you reactive power, but 600 kilowatts. I think we see nothing. Okay. PV power.
Not really much. It's a little bit cloudy today.
Okay. The same as yesterday. Tilo, come to Chennai. Sun is shining. Okay. This is the overview. The consumption now at this time in Schwäbisch Hall. What time is it, Tilo, in Schwäbisch Hall?
Now we have one moment. 12:30.
12:30. Yeah, it's a break. It's a break. All people are eating. The industry is going out. Okay. Normally it's just normally 1 o'clock or 2 o'clock we are again 50 or more. Now can we show? Right, Tilo?
No.
Can we show it?
The graphic?
Yes, a graphic, right?
No. I was in the simulation mode, sorry.
Yeah.
Now it should work.
Okay.
So,
yes, okay.
yes, we had a big consumption today.
Yes.
Around about 50 megawatts.
Yeah. And in the night, you know, not more than 20 megawatt, right?
Yes, yes.
Okay.
Around about 20.
Okay. Thanks, Tilo. Now, was the next topic, PV power plant Michelbach.
PV power plant Michelbach.
Yeah. Near my house. I think 200 meters. Victor lives also before he went to Schwäbisch Hall. Near my house. Okay.
I'm searching for it.
Okay. Yeah, it's a big system, more than 1 million data in the system. It's not so easy.
Oh, I think there's a connection problem.
Ah. Yes, okay. I think so. We must use a new RTU, thermal unit. Okay. So, Tilo, so the next topic. What was the next?
What was the next?
Great question.
Yeah, any questions now?
Yeah, we can show it online. Okay. You have a question or?